Hello friends, welcome back to series of online lectures on non-conventional machining. During my previous lectures, we have discussed on why do we need non-conventional machining processes, how to classify non-conventional machining processes. Then we have seen what are the different main characteristics of conventional machining and non-conventional machining, and also we have taken overview of all the non-conventional machining processes. In today's lecture, we are going to discuss about similarities and differences between conventional machining and non-conventional machining. Before that, I would like to talk about conventional machining. As we know that by definition, machining is a one of the secondary manufacturing process by which excess material is gradually removed by the shearing from the preformed blank in the form of solid chips using a edged cutting tool, okay, in order to get desired shape, size, or we can say finish and tolerance on that our product. Again, it follows the subtractive manufacturing approach to fabricate desired object, correct? So if you take the example like turning, threading, facing, then drilling, boring, or milling, etc. Such a conventional machining processes are unable to cope up with even growing demand for miniaturized product with higher surface quality and close dimensional tolerances. Also, newly developed materials which display unacceptable machinability in many occasions. So all these limitations paved the way for finding our alternative machining process that can be satisfactory process with the wide variety of material, as well as it can produce surface finish in the range of nanometers with improved accuracy. So to fulfill this requirement or to overcome on that limitations, many traditional non-traditional machining or unconventional machining have emerged to meet the need of market. Okay, so if I will talk about the non-conventional machining, then in non-conventional machining processes neither shearing occurs nor chip forms. In fact, such processes does not utilize a so-called cutting tool also. Instead of only mechanical energy, various forms of energy like mechanical, thermal, electrical, chemical, electrochemical, or light, etc., are used in direct form in a such non-traditional machining processes. For what purpose? To remove the material. Correct. So material removal is also realized in several ways, such as by erosion, then chemical dissolution or ionic dissolution, melting and vaporization. So there are several non-traditional machining processes like, or I can say, for example, abrasive jet machining, ultrasonic machining, electrochemical machining, electro discharge machining, laser beam machining, etc. So each process has their distinct capability and they are suitable for specific purposes only. So now we'll discuss the various similarities between conventional machining and non-conventional machining. Okay, so first similarity between these two processes are both the processes belongs to the machining processes, and thus both the processes are used for the removal of excess materials. Again, both are subtractive manufacturing process, top to down approach used. Okay, so both are subtractive manufacturing process. Then both are secondary manufacturing process. Again, this is a similarity, and both can be produced sufficient, smooth, and finished surface with close tolerance. Although different processes have their different capability. Okay, so these are some points or similarities between the conventional and non-conventional machining. Now let us discuss about the difference between conventional machining and non-conventional machining. Now here I have made two columns. In first column you will get the points regarding conventional machining. In the second column you will get the points regarding the non-conventional machining. Now first difference is that In conventional machining, only mechanical energy, that is the power, is utilized to gradually remove excess material from the workpiece. Okay, to remove the material from the workpiece, only mechanical energy is utilized in case of the conventional machining. In non-conventional machining processes, various forms of energy like electrical, chemical, thermal, mechanical, or light, etc., are used, or I can say, or combination of two or more than two of energy sources or energy forms are directly utilized for removal of the excess material from the workpiece. Okay, then second point about the conventional machining is that materials are removed in the form of tiny, sharper chips only. Okay, but in case of non-conventional machining, so-called chips or chip is not produced here. Material is removed in various forms such as tiny metal particles, ions, molten or vapor, etc. Okay, for conventional machining, sharp deformation is the only phenomena that causes the removal of the material. In case of non-conventional machining, shear deformation plays an insignificant role in material removing in most of the non-conventional or non-traditional machining processes. Instead of that, shear deformation, erosion, dissolution, vaporization, splattering, etc. occurs in non-conventional machining. Then for conventional machining, a sharp edge shaped cutting tool having specific geometry as well as material and properties required for cutting action. So for conventional machining, we require sharp edged cutting tool. In case of non-conventional machining, so-called cutting tool does not exist. Okay. However, in few cases, for example, electrochemical machining or LED discharge machining, tool is required, and its a profile and property must match with the requirement. Okay. So this is a requirement of non-conventional machining in case of ECM and EDM. If you talk about the conventional machining, physical contact between the cutting tool and workpiece and also relative velocity in between them are indispensably necessary in order to remove material. So this is a basic condition in case of conventional machining. In case of non-conventional machining, although no physical contact occurs between the cutting tool and workpiece, but in few processes such as abrasive jet machining, abrasive water jet machining, and ultrasonic machining, solid abrasive glides or I can say particles strike the work surface to erode the material. Okay. Now, another point about the conventional machining is that these processes are age old and thus physics of the processes are well understood. So skilled labor are also readily available at comparatively cheaper cost. Okay, this is general point about the conventional. In case of non-conventional machining, most of these processes are developing. So labor cost is also high due to less number of skilled labor available in this advanced machining processes field. Okay, in conventional machining, it can provide a wide range of surface finish, but depending on the process that is employed and also the process parameters. Okay, but however, getting surface finish below 10 micron is quite difficult using conventional machining, and also for this requirement, it requires CNC system also using conventional machining. But in case of non-conventional machining, as achievable surface finish is much better than that for conventional processes. Non-conventional machining can easily provide a surface finish in nanometer range. So this is a positive point or plus point about the non-conventional machining. Then conventional machining processes are suitable for bulk removal of materials. Again, in this sense, these are fast, reliable, and economic. That is a higher material removal rate, that is MRR, will get using the conventional machining. Non-conventional machining processes are suitable for highly accurate and precise requirement. Okay, please note down this: accurate and precise requirement. For bulk removal of materials, these processes are time consuming, less reliable and uneconomic. Okay. Then conventional machining processes are certain shape. There are certain shapes that cannot be produced by this conventional machining process, and non-traditional machining processes sometimes become a reliable option for producing such critical shape or integrate shape, or I can say complex shape. Now, examples of conventional machining processes are turning, facing, growing, drilling, boring, rimming, then shaping, planing, milling, grinding also, okay, honing also. These are the examples of conventional. In case of non-conventional machining processes, following are the examples such as abrasive jet machining, abrasive water jet machining, ultrasonic machining, electric discharge machining, electrochemical machining, chemical machining, then laser beam machining, plasma arc machining, electron beam machining, ion beam machining, and also hybridization of these above all processes. So these are the examples of non-conventional machining. So this is about the similarities and differences between conventional machining and non-conventional machining. So here I have mentioned some references from where I have taken this data. Okay.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.